to introduce the chapter number 14, Semiconductor Electronics, Materials, Devices and Simple Circuits. What is electronics? Electronics is a branch of science and technology which deals with the study of design, use of devices that depend on conduction of electricity through gas, vacuum or semiconductors. So in the earlier days, almost all devices like a transistor, radio, TV, they are very large in size, bulk in size, because all the materials are made up of vacuum tubes. There are different types of vacuum tubes with 2 electrodes, 3 electrodes, 4 electrodes, etc. Diode, triode, tetrode, pentode, etc. And here in such vacuum tubes, vacuum is required in the inner electron space, otherwise the moving electron may lose their energy on collision. So vacuum is maintained between the 2 electrodes, and such vacuum tube devices are bulky, consume very high power, operate generate very high voltages of 100 volt, and they have limited life and low reliability. And after the discovery of semiconductor electronics or solid state semiconductor electronics, now most of the electronic devices are made up of semiconductors, and if semiconductors are used as the materials in electronic devices, they have long life, they are small in size, they are compact, they consume very less power, operate at very low voltages, and they have high reliability also. Some of the semiconductor electronic devices, diodes, transistors, IC, then what LED, LCD, photodiode, solar cell. Almost all electronic devices used in our house are made up of semiconductors. So that is the importance of semiconductor devices and semiconductor electronics. In this chapter we will study more about a semiconductor device called a diode. Before starting the chapter, before studying about diode, first we can study the classification of metals, conductors and semiconductors. We know on the basis of the relative value of electrical conductivity or resistivity, all solids are classified into metals or conductors, semiconductors and insulators. Now metals or conductors, they have very high conductivity and low resistivity. And the metals or conductors have resistivity. Rho means resistivity, approximately 10 raised to minus 2 to 10 raised to minus 8 ohm meter, and conductivity is 10 raised to 2 to 10 raised to 8 Siemens meter raised to minus 1. Ohm raised to minus 1, meter raised to minus 1. Then semiconductors, in semiconductors conductivity and resistivity are intermediate to metals and insulators. And for semiconductors, the resistivity 10 raised to minus 5 to 10 raised to 6 ohm meter, and conductivity 10 raised to 5 to 10 raised to minus 6 Siemens meter raised to minus 1. And insulators, they have very high resistivity and low conductivity. And resistivity is very high, 10 raised to 11 to 10 raised to 19 ohm meter, conductivity very low, 10 raised to minus 11 to 10 raised to minus 19 Siemens meter raised to minus 1. In this chapter, we confine our studies on semiconductors. What are semiconductors? What are the different types of semiconductors? Elemental semiconductors, compound semiconductors, and different devices made up of semiconductors. So what are semiconductors? And here the conductivity and resistivity are intermediate to metals and the insulators. They have resistivity of the order of 10 raised to minus 5 to 10 raised to 6 ohm meter, and conductivity of the order of 10 raised to 5 to 10 raised to minus 6 ohm raised to minus 1 meter raised to minus 1. Now we can study the classification of semiconductors. Semiconductors are broadly classified into 2, elemental semiconductors and compound semiconductors. Elemental semiconductors, example silicon and germanium. They belong to the carbon family. Only 2 types of elemental semiconductors are there, silicon and germanium. Compound semiconductors are of different type: inorganic, organic polymers. Inorganic semiconductor, example gallium arsenide, cadmium sulfide, etc. Then second one is organic semiconductor, organic compound semiconductor, example anthracene. Organic polymers, example polyaniline, etc. So many organic and organic polymer semiconductors are there. And here in the chapter we will study more about the elemental semiconductors like silicon and germanium. Now we can discuss the energy bands in solids. In an isolated atom, electrons have well defined energy levels. Each electron will have different energy level. So these different energy levels will form a range of energy levels, and this range is called energy band. Okay, so energy band means the range of different energy levels is called energy band. For example, an energy band, for example, some electrons are having energy level 2 electron volt, some electron having energy 2.1, and some other electron having energy 2.2 or 2.3, 2.4, 2.5, etc. So this from 2 electron volt to 3 electron volt, that energy range of energy levels forms an energy band. Okay, so electrons having energy levels between 2 electron volt and 3 electron volt, that range of energy levels forms an energy band. Okay children. Now there are two types of energy bands. First one is the valence band and second one is the conduction band. Energy bands which include energy levels of valence electrons. So all the valence electrons do not have the same energy. Okay, so the range of energy possessed by the valence electrons, that is called a valence band, and the range of energy possessed by completely free electrons, that is called a conduction band. So two types of energy bands are there. Valence band, that means the range of energy possessed by valence electrons, or the energy band which includes the energy levels of valence electrons, that is called the valence band, and the range of energy possessed by completely free electrons, that is called a conduction band, and the conduction band lies above the valence band. The energy band above the valence band is called a conduction band. Now energy band diagram of metals. So metals, we know that there are two types of energy bands, valence band and conduction band. So here this represents a valence band and this represents a conduction band. Conduction band is above the valence band. Okay. So in the case of metals, even at very low temperature, we know that metals conduct electricity. That means valence band and conduction band overlap each other. So even at very low temperature, electrons can move from valence band to conduction band and helps in conductivity. That means valence band and conduction band overlap each other and there is no gap in between. Okay. That means in the case of metals, valence and conduction band overlap. There is no energy gap in between. There is no space in between. Conductivity is very high and conduction band is partially filled. Now second one, semiconductors. Semiconductors, valence band and conduction band are separated and the gap in between is called forbidden energy gap. Okay, so the energy gap between valence band and conduction band, that is called forbidden energy gap. Forbidden energy gap. That is represented by Eg. Why it is called forbidden energy gap? Because no electron can retain or no electron can stand in between the valence band and conduction band. Hence it is called forbidden energy gap. In the case of semiconductors, forbidden energy gap is less than 3 electron volt. Okay, that means at very low temperature, electrons cannot move from valence band to conduction band. Only at very high temperature, semiconductors conduct electricity. So there is a forbidden energy gap of less than 3 electron volt. So at room temperature, some of the electrons, at very low temperature, no electrons can move to conduction band. But as the temperature increases, electron can move from valence band to conduction band. So for semiconductors, conduction band and valence band are separated by forbidden energy gap less than 3 electron volt and the conductivity lies between conductors and insulators. Then third one, insulators. In here also valence band and conduction band are separated by forbidden energy gap and here the energy gap is very much greater than 3 electron volt. Okay, so the valence band and conduction band are very large separated and the forbidden energy gap is very much greater than 3 electron volt. So even at very high temperature, electrons cannot move from valence band to conduction band, and hence insulators does not conduct electricity. Okay, because the forward energy gap is very large. So for insulators, forward energy gap is very much greater than 3 electron volt. Conduction band is completely empty. Conductivity is very low. Conduction band is completely empty means no electrons can move from valence band to conduction band even at very high temperature, because this energy gap is very large. Okay, so that is the energy band diagrams of metal, semiconductors and insulators. Once more, in metals, valence and conduction band are overlaps. So even at very low temperature, electrons can move from valence band to conduction band. In semiconductors, valence band and conduction band are separated by a small forward energy gap of 3 electron volt, less than 3 electron volt, approximately 1 or 1.1 electron volt. Okay, very less than 3 electron volt. Therefore, at a very high temperature, some high temperature, at room temperature, electrons can move from valence to conduction band, and hence semiconductor conduct electricity at room temperature and higher temperatures. And insulators, forward energy gap and valence band and conduction band are highly separated, and the forward energy gap is much greater than 3 electron volt, and hence conduction is very less.